I'm Charlie Clemmer. You can find me on Twitter at Charlie Clemmer. Kind of a recent development as we started getting into this without all the whiskey or the rest of it, but working through the lab or the hands-on part, ran into kind of some interesting development that steals some of my thunder. So the premise behind the presentation really kind of spun out from Peter's keynote last year, talking about when we look at a big mobility domain and you've got a lot of different IP addresses, and does it make sense to do VLAN pooling and small subnets or a larger subnet and kind of go from there. There was the thought behind go with a larger /16, it would eliminate problems with IPv6. I got into it, started digging with recent code, both on the Aruba side and on my Cisco controller, and found that really isn't as much of a problem as it was. But we'll kind of go through what I wanted to do here. It's an introduction to IPv6. Turn it around a little different. Show of hands, who runs IPv6? 4 people, okay. And that's about what I expected. So, yeah, that's where I have it, is at home. Except on my modem, but we'll deal with that. Yeah. So it was really kind of wanted to bring up IPv6 as a topic. I think there's getting a lot more talk about it lately. I think Aaron has kind of got the full-scale alert going. They're down to like a quarter of a Class B remaining from an IPv4 assignment perspective. So kind of expect that more questions will come up about it. So just wanted to kind of present not a full in-depth, let me go ahead and jump to the agenda, not a full in-depth of what is IPv6 and the ins and outs of all of it, but specifically, why do you care as a wireless guy? So looking at it from that perspective, what am I going to cover? What's relative to you guys as wireless guys? As we're building out these networks, we've got guests coming on or we're using production devices. What do I need to take into account when I'm designing a network to support IPv6? What I'm not covering is a lot of the other things. Tim came up earlier and mentioned a book that he had seen on IPv6 addressing. We could spend 4 hours talking about the right way to address subnets, and do I do /64s, do I do something deeper? So not really going down that path, but just wanted to stay focused more what's relevant to us. And then at the end, I've got a couple of slides. We'll do a little hands-on. I was a little, after Rick's 2 presentations, skeptical about standing up an open SSID so I can do packet captures and there's no security. And so if I get pwned later, I know who to call. But we'll do that, and then I've got a couple of references or resources that we can hit up if you find yourself in a position where you need more info. So, at a high level, the obvious piece that I think we've all heard about is IPv6 has got a much larger address space. So in theory, I don't run into the same issues around, do I need to use NAT? Do I need to come from my addressing from a scarcity perspective where I've only got a finite number of devices? Do I really want to allocate that? Am I allocating something larger than a /24 because I need the host space for it? Or am I worried about broadcast domains or what? We really get to take that whole, how big of a subnet do I use, off the table. If I do a /64, I can fit everything in there, and then it's just a matter of, what context do I put on top of it? There's new packet formats. And so I really had to steal the theme that we keep using all week is, what's dead? 2.4's dead. I forget, there was something else that was dead. Broadcast or dead. And just to make it clear, broadcast or dead. It's a good thing and a bad thing. And it really kind of is the linchpin of the whole discussion. So as we move from broadcast, so broadcast for DHCP discovery, for anything, for any of my discovery, a lot of it's all moved over to multicast. Multicast is the only way to contact multiple devices. But at the same point, so talk about like ARP versus broadcast or DHCP. So rather than using those type of broadcast mechanisms for identifying or resolving who's got what Ethernet address, who's got what IP address can I have, that I'll move multicast. Okay, so we didn't want to do broadcast because we were worried about broadcast domains and how much broadcast traffic am I hit with, and I still have to go interrupt the CPU and all that good stuff. So multicast is better, right? Except that we still have an all nodes multicast address, which is going to effectively do the same thing. I need to listen for neighbor solicitations and the rest of it. So there's a little bit of a trade-off back and forth. But what's bigger here we'll get into is kind of how some of the things we take for granted as far as packet flows go, how that's changed. Wanted to go through a couple of different address types. Really the idea here is not so much to do the eye chart and try to memorize the different addresses, but really to point out that there are different addresses available. So the old ::1, it's the 127.0.0.1, your loopback address, right? Your home address. New notation as far as how we list it out. But some of the interesting things I think are when you get into link local. So every device, whether it gets an IP address, an IPv6 address from the infrastructure or not, if it talks IPv6, it'll have a link local address. We'll use that link local address for a lot of the low-level communications that take place for finding somebody next to me and what my router is, those kind of things. There's the concept of unique local. So think of that as RFC 1918 space. It's the address range that I can use non-routable inside my own space. I can route it in my own space, but it's not going to be routable out to the internet. You've got the multicast addresses, and then you've got global unicast, and that's my prefix there on the bottom. But again, really trying to highlight, I'll bring it up on my laptop here when we get into the hands-on piece to show you, but the key point being, when a device has multiple addresses, where we're used to troubleshooting, here's my IP address, am I mapped to the right VLAN, do I have routability? First thing you'll notice when you get in here is we've got potentially 4 different addresses, and so what's being used to talk to what? So a couple of the requirements around it, which addresses are always going to be there, which ones are optional. Again, you're going to, we'll have a unicast address. The anycast address may be optional. We may be doing that or not. The all nodes multicast, there's also an all routers multicast address that we'll use for more of the auto configuration piece that I'll get into here in a second. Multicast is optional. And the bottom comment there, the routers will be listed on the all router multicast address for things like router solicitations and those kind of things. So just highlighting some of the different addresses that'll be there. ICMP v6. So we've changed a little bit as far as ARP and those broadcast mechanisms before have changed. We'll do a packet capture when I bring I think my iPhone online, and I can kind of see that whole conversation that goes through, but it used to be very straightforward. You bring a device up after we did all the 802.11 stuff to get on the network. We'd go out, send out a DHCP discover broadcast. It gets relayed if I'm not local to a DHCP server, et cetera. You get an offer back. We send out a request. We get an acknowledgement, et cetera. It's a little more complicated here. So instead of that ARP mechanism, we'll do neighbor solicitations, neighbor advertisements. We're using that for the neighbor discovery. So I know I want to talk to somebody next to me. What's the physical address? Can't send a broadcast. We'll send a multicast through ICMP v6 and discover it that way. Effectively, like I said, this replaces what we have with IPv4 ARP. It also then gets extended, though, to look for things like router discovery. The next couple of slides deal more on the router discovery piece, but just to know that this is part of that whole DHCP process, although DHCP is optional or not, and getting a little convoluted. But the second piece then is we use neighbor discovery to figure out if I derive an address. So if I use the auto config to come up with my own address, I don't need a DHCP server. How do I make sure that address is unique? We'll use that link local address, send out an ICMP v6 neighbor solicitation. Is anybody using this address? If I get a response back, I know I've got a duplicate address. I need to go try again. If nobody responds, I'm good, and we'll go from there. And really, that's probably one of the biggest differences is that with v4, we knew I was either running a static address or I was using DHCP, pretty cut and dry. With v6, I can use a static address, I can use an auto-configured address, I can use DHCP, I can use an auto-configured address with DHCP. I start to get a lot of different permutations, and then you add on top of that I could have multiple prefixes running on the same wire, so start multiplying that out on the different permutations. So with router discovery, again, these are ICMP v6 messages. When I run the Wireshark, we'll look at just filtering for ICMP v6 to kind of get out all the other background traffic. But there's 2 components. There's the router discovery. I probably should have ordered this in a little different order. There's router discovery, or router advertisements, where the routers, the IPv6 capable routers, will send out multicast saying, here's the prefix, or here's a prefix for this wire. That that occurs at a fairly long interval. So when a router, or when a device comes up, most often it'll send a router solicitation. Rather than wait for the advertisement, we just ask, where are the routers on my subnet? It's sent to the all routers multicast, and that triggers off then the router advertisement. So we'll do a router advertisement in response to that solicitation, or we'll do a periodic multicast of it so that anybody that's out listening can hear. Key piece is in the router advertisement, there's a lifetime. So anybody that's done kind of IP readdressing in the v4 world, we got into multi-netting. I'd put 2 different IPv4 subnets on one wire. You didn't have a way to really kind of differentiate or preference. Here's my prefix that I want you to use. Here's the one that you can kind of use temporarily. We've got both a lifetime. There is a priority or a preference attribute here. We're also sending back what we want the default route to be. So it gives us another way to kind of go back and do that dynamic discovery piece. The last bullet here ties back to that last piece. You can use through the router advertisement also notify when do we want to use DHCP. So am I going to use DHCP just to push options out? Things like my domain name, DNS server, those kind of things. Or are we going full stateless? So from a stateful piece, very similar to DHCP v4, we're going to come back, talk to a DHCP server, get a lease from there. I've got some other box somewhere that's keeping track of where I'm at. We use that to push out a lot of the other additional parameters. Again, your syslog, NTP time server, all that good stuff. The stateless piece, so 2 modes. I can do stateful, where we're doing the addresses, or I do stateless, where DHCP is only providing those options, and we'll use the auto-config piece to grab the address. From an address selection piece, I kind of hinted on it earlier, we can have multiple addresses, we can have multiple prefixes. So the system has to have some method for determining which address do I want to use when I'm trying to contact a host. Most of them, it is something that we can configure, we can have some influence on. Most systems will try to defer to or default to IPv6 first if it was successful in getting an address. If I get multiple addresses, you get into ordering as far as what prefixes, those kind of things, or priorities that we had to figure out which ones to talk through. Again, this is important from us from the perspective of if I have guests coming on or I've got users coming on the wireless network, am I controlling router advertisements or the responses to router advertisements? Do I have guests that are getting multiple different addresses? Do I know what those addresses are? Are they routable or are they not routable? A lot of the help desk problems then could come back to a client gets a valid unicast IPv6 address, but it actually doesn't go anywhere, or it points to somebody else's router. It may not be behaving the way they want it to, but it comes back and looks like it's a wireless problem. So this piece and the next piece, or the next slide, are really kind of what prompted me to bring up the discussion. The conversation last year, and as we first started looking at this, was great. With everything being multicast, what happens when I do get into that VLAN pooled? I've got one SSID, but I'm potentially steering people to different VLANs, either randomly, just as they connect, or as a security policy. I'm doing an RBAC type model where I can recognize one user's laptop as an administrative laptop, somebody else is a student, somebody else is a guest, and so we're going to use radius response attributes to steer them to different VLANs. However the mechanism is, you always had that possibility that multicast, even in an encrypted SSID where we're sharing that group encryption keys, I could potentially see multicast off of different VLANs. So I'm using that multicast to determine what my IP address is potentially. Do I have a problem there? Plus side, when I was going through revalidating my lab for tonight, I did see that there's been several inclusions across different vendors as far as how we handle multicast optimization and an IPv6 awareness of that. So with most vendors, we got into understanding that I didn't necessarily want to send a multicast out at the lowest basic data rate that we support. I need to send it that way to make sure everybody gets it. But if I'm doing things like IGMP snooping to listen to what multicast groups individual clients are interested in, maybe I can send that multicast to them at a higher data rate and still ensure that they actually got it. So if I get everybody up off those lower data rates, I'm freeing up some airtime. helping out there. The router advertisement piece and what I've discovered off the two systems that I was testing on last night was we're actually, it used to be a knob for us where I could set whether or not I wanted to unicast those router advertisements, whether they were unicast or multicast. Now it's on by default. We just automatically unicast it. So when we get in the packet capture, you'll be able to see that. But that helps eliminate to make sure that if I've got two different devices on the network, one on VLAN 100, one on VLAN 200, when they send that router solicitation out, the guy on 200 is not going to hear the one from a layer 2 perspective, isn't going to hear the response that comes back. The guy on VLAN 200 will hear the advertisement that he needs to hear. The guy on VLAN 100 hears his appropriate advertisement. So second piece of that then is outside of just dealing with multicast, the fact that we have different addresses and we use different addresses for different things comes into play if I'm doing any kind of port level ACLs, firewall rules, those kind of things. I need to be careful as to what I'm firewalling, what do I allow, what do I not allow. The first time I started playing with the HP cloud service and trying to get my blog and some other stuff out of the house and somewhere maybe reliable, I was trying to turn on IPv6 back to Hurricane Electric and went through and just locked down anything that wasn't coming from my global prefix. And then realized neighbor discovery didn't work across my 6/4 tunnel because I had cut off all that link local traffic. So it's understanding the different pieces, what protocols or what addresses come into play as we talk. We do the discovery, we do the router discovery and go from there. The second piece that I've run into is when you're doing service discovery. So I think everybody's familiar with the lovely Apple TV as it sends out those MDNS broadcasts saying, hey, I'm an AirPlay device, here's how you can contact me. This comes into play again. So if we were able to derive an IPv6 address intentionally or accidentally, those advertisements then will say, you can also reach me on this V6 address. Well, what happens if I'm on a network that we didn't enable V6 on? Does my device try to talk on that V6 address? Do we go looking for it? Am I in a place where I just don't have routability? So maybe I do have a V6 address, but I don't have routability to that Apple TV's V6 address. So understanding if I intentionally decided to go put V6 out there, then great, let's make sure we've got routability. But then on the help desk side or on the back end, the troubleshooting piece, if I don't intend to put V6 out there, what are my safeguards to make sure that we're not actually defeating ourselves or shooting ourselves in the foot by running V6 or having V6 pop up sporadically. I'm going to jump over here to, I need to figure out, get my Wireshark over. And it's not that way. And it's not that way. All right, where is my monitor? I swore I was not going to be the guy to have the display problems with Apple. Tells me it's to the... All right. Now the fun part, I should have just probably mirrored. So, actually that's exactly what I'm going to do. This way I can see what I'm showing. So I had a capture going, and we can turn this on if anybody else wants to jump on here. The one other fun thing that I had working in here, we've got enough APs, there's enough other devices in here, so trying to find a channel that nobody else was on, I went ahead and just picked a DFS channel and was reminded that even though a lot of devices support 11AC, a lot of them don't do DFS still. So I've kind of limited this down to just two devices. I've got a Galaxy S4 and my iPhone 6 over here that we did a connection with. But you can kind of see as I was running through this packet capture again, just looking for IC and PV6, so it does strip out where the association took place. But this is where my device first connected. So first thing we do when the device comes on, and again, I'm not looking at any of the V4 stuff. There would have been DHCP, all the rest of that taking place in the background. But the first thing we did was send out a router solicitation. I sped up the general router advertisement time on here. Instead of defaults are 10 minutes. I went ahead and set it up to, let's just go ahead and advertise every 10 seconds. Seemed good, gives me more traffic. So we sent out a router solicitation. We get a router advertisement back. And this is one of the fun things where, as I start to dig into it, we can look for things like what address am I using. If we get into the different, so I've got my prefixes here. As we get into the different VLANs and those kind of things, tracking back through here, I'll see it all, but I can still figure out from a packet capture what VLAN did I think you were in. Once we got connected, we'll start going back looking for neighbor solicitation messages. So I'm looking for things like, great, my router advertisement said, here's my default gateway. What's the physical address of that? The router advertisement told me, here's my DNS server. Great, how do I figure out back to there? Again, if it's not on subnet, then I need to go route for it. I'm going to go ahead and turn this cat, and this was a great tutorial earlier on how to do Wireshark natively, so I'm not doing another VM. All right, there is an SSID in the air. It should be pretty obvious if your device listens to or is able to talk on DFS. It's Clemmer 6-A. If anybody wants to join, give me some traffic. I see we've had some people join. I'm going to stop there because that should give me what I needed. So when I look at things, should have a number of clients. We should end up on a couple of different VLANs. And so as I come through here, let me take on my router advertisements. Just want to look at my advertisements. Come down here, I see kind of from one device that comes up, he's on VLAN 100 for me. It has a prefix. The last part of there, I'm not very generic. Anybody remember IPX? The old Novell routing protocol? Yeah, we can have bad dad and all those good things. So yeah, I have bad, I have CAD and dad. It just, AAD seemed, yeah, that's me. So as we jump through here, I can see where I've got those advertisements, and actually it looks like, oh, there's a D. So I'm on one channel, I'm on one SSID, just basically sniffing everything, and I can see that I'm getting these router advertisements back. So there's a B, there's a D. Now, what's proven to be interesting and why I think this is still useful, anybody dealing with legacy gear, and I know everybody's got latest and greatest, brand new controllers, latest code, all that kind of stuff, right? Nobody runs autonomous APs or anything like that. If you find yourself where you bring up your terminal window here and you say, hey, I want to look at my network adapter, and oh look, I've got an IPv6 address here. That's my link local. I've got two different IPv6 addresses over here. Now these are both on the same VLAN. But this is kind of what it would start to show up as. In my case, we're going stateless. We're doing the auto config. A couple interesting things about auto config that could show up. We can do a couple different things. I can just generically pick the MAC address, stuff it into the back end of the prefix, and say I'm good. I know it's going to be unique. Nobody else should have my MAC address, so we'll be good there. It also gives an easy way to track me as I move around to different networks because my MAC address is in all my IP addresses. Probably makes it too easy from a tracking perspective. So the other piece that we can do is where we start getting into more of a privacy option. So we'll go back and randomly regenerate what these addresses are so that if that last part of the address is always changing, now it's a bit harder to track me. I'd have to actually do that ARP or that neighbor advertisement piece to keep track of what address have I used or have I rolled over as we've gone through time. Now, if I've got a voice over IP call up or if I'm doing web surfing, those kind of things, I've got connection-oriented protocols up. I don't want to just change my address. But so here's one of the ways where you would see what are all the different addresses that we're using. If I'm rolling through from a privacy perspective, there'll be some time where I have an overlap. So let's keep an eye on those. Is there a question? No. So what I wanted to get into here is really more looking at this from the radio side. And what I can tell is, where is that? It's not down there. All right. What I'm trying to get through to is where my, here we go, receiver addresses and destination addresses. So we mentioned, if you look at the source, well, actually the source is a bad example. You look at the destination. The destination is a multicast. It's the FF02::1, so the all nodes address. It should be a multicast. We should be flooding it out everywhere. But when you look actually into the packet, you can see I've got my destination address is actually, or both the receiver and the destination address are my physical addresses on whatever this device was. So from an L2 perspective, we did a unicast, making sure that somebody else that's on here, we're not seeing it. It's not being sent out to all nodes on the wireless side, but instead coming out through direct unicast. So it's able to take advantage. If I dig up where my speed was, I think I saw that in OmniPeak last night, but basically you would see it's using the higher data rate. It's not using the basic data rate. Any questions? All right, the last thing that I had then, and we can get in and play with other things if we want, or kind of go from there, but a couple of different resources. We're going to do that. So a couple of different resources that are available that I found useful as I'm getting into IPv6 and working with it more. The first one is so it is a former employer of mine, Infoblox, but Infoblox does have a blog site. It's the IPv6 Circle of Excellence, or Center of Excellence. Lots of good information there. It is in a blog format, so more Q&A or as different things come up and are timely, there'll be answers there. The other piece, the second piece there, the two URLs are for Hurricane Electric. Anybody who's not familiar with Hurricane Electric, they're a service provider out of California. They do a very large backbone across the world, but the biggest thing they have is that tunnel broker address, the second one. You can get a 6/4 tunnel to your house, get IPv6 connectivity, play with it. Part of it, they'll assign you a /48, so you can go crazy with your subnetting. And they've got a couple of good blog sites there as far as how do you set up those 6/4 tunnels. The only interesting thing that I saw there is I'm always looking for backdoor ways, either using a sense firewall. I've got a Vieta router inside of ESX. You can use iOS routers, but Pix firewalls and some of the other things don't do 6/4. On Twitter, two other resources. And actually, so the first one on Twitter is E. Horley. Ed Horley has done a very good book. It's written for Windows administrators, but it's focused on IPv6 for the Windows administrators. Jeff Carroll is located here. He's done some training with the Rocky Mountain Summit with Aaron, et cetera. And so I mentioned Ed's book. There's also a book by Cisco Press just on general IPv6 fundamentals. It's a very thick book, but goes into great depth there as far as the different things to look out for. So with that, that's all I've got. Any questions or anything to jump into? Yeah.
Do you think organizations will use unique link local, or will they go fully routed inside? Or I shouldn't say that unique local, right? The old RFC 19.
Right.
Do you see companies using that, or go full routing all the way in?
I think there's two different mindsets that will play out there. Yeah, so to restate the question, it was basically, would we do unique local, or do we expect to see organizations do unique local, effectively map back to what we were doing with Network 10, the RFC 1918 space, or use actual public IPs? Ultimately, I think that ends up being a religious discussion or a religious kind of answer, where you have guys that felt that there were certain security barriers by running NAT. They may be inclined to do the unique local, or the RFC 18, the non-routable space, keep that inside and then use some sort of proxy or use some kind of NAT device to NAT on the way out. The benefit to V6 is that I don't need any of that. So then it just comes down to, do I have the belief that NAT is providing me functionality from a security perspective, or was it just an address conservation technology? From my belief, I expect that I expect that you'll end up seeing the globally routable addresses, that there'll be a delay, that there'll be some hesitation. There'll be people that kind of dip their toes in the water. They do what they're used to doing. They try to NAT, or they try to go through a proxy, et cetera. And ultimately that starts to change. Mostly either driven by religion, like I said, or based off this idea that while we're just getting started, how many IPv6 addresses are there? Do I need to be conservative when I get started? Or do I have a colo provider that's only giving me a /64, so I don't have a good way to subnet it? Not really a great answer, but unless there's any other questions, otherwise yeah.
Increases in radio utilization before and after enabling V6 or dual stack.
Increase in radio utilization?
Yeah, from neighbor discovery messages and all of the overhead that comes along with that.
No, so that was a good point. That was one of the things I meant to highlight on the packet capture. You do see more traffic, I think, when you first associate, as far as the two router solicitation, router advertisement that go back and forth, and then all the neighbor solicitations, rather than your four-way, DORA discover, offer, request, acknowledgement piece. But if those, as I was seeing, are more, now they're optimized, they're not going out at your broadcast rate. We were actually sending them at unicast data rates. So it's more packets, and that was what I was expecting to show you guys, was here's the doom and gloom. It's going to be low data rate stuff, and I'm hearing all this traffic and getting addresses on the wrong VLANs. By this point, most vendors have gotten to the point with their IPv6 implementations that's been pretty well negated. Doing that DMO conversion, or the dynamic multicast optimization conversion to unicast, helped a lot with that from that perspective, from what I've seen. Yeah, Andrew.
I just have a question relating to scalability with IPv6 now that we have /64. Typically, subnet sizing in the large density environments. I haven't done one on IPv6, but I was wondering if anybody in Aruba has done IPv6 on those large networks, and if there's anything that, like, lessons learned of, does it work better, does it work worse, or certain tunings you need to do to make sure that you don't end up with very large subnet sizes that hurt your performance at scale.
From me personally, like we did the show of hands at the beginning, I think there were 4 people in the room that have done V6 so far. I'm hearing more questions being asked about it. I'm not seeing it as much. And kind of to Chuck's point earlier, if you're not using it, my general best practice or general recommendation was, if you're not using it, to turn it off, or otherwise make sure that we're not getting a conflicting or a hidden kind of IPv6 network that's running that I don't know about. Chuck, I don't know if you've run into it anywhere in any large public venues, but I'm anticipating no by the...
I'm not aware of any that are running it.
Okay.
That are our customers.
Yeah, so I think it's still early on there. If I was holding out hope for something, it's as we get back into the dynamic multicast optimizations and being able to do that conversion from an L2 multicast to unicast, it's that we're also then keeping track of where users are. We've been able to do that successfully on some IPv4 deployments, the larger ones where we start recommending a /16 instead of the old broadcast piece, because I know where everybody is, so I can effectively rule out that broadcast traffic. And I would expect that to carry over. I just don't have any actual data points to say, yeah, here we did this, and this customer had 32,000 devices on one subnet, and we're great. Jake, did you have?
Yeah, start a religious war here. Slack versus DHCPv6. What are your thoughts in terms of wireless deployments today and or moving forward?
So I don't know that I have, from an operational perspective or a performance perspective, a bias one way or the other. My tendency, I like having the address come from DHCP because I have someplace to go look and find it. But that's just me being nerdy and wanting to have reports to see what addresses were used and how do I track it and all the rest of it. Slack definitely speeds things up. It allows me some of those other mechanisms for either security by being able to change the address over time or as data goes on. And it's definitely a lot easier to set up and run if I'm just doing a demo. That's what we've got here. It's just running Slack. But it's speed or ease of deployment versus having the accountability on the back end. Do I have another question? Sure.
kind of back to the previous topic and just forward. So I've not done a whole lot of V6 except in the house, and certainly not at LPV scale yet. But I am not bought into unicast conversion as a high density solution. So unicast conversion works fabulously for video, because with the data, you saw the data I showed in terms of airtime consumption. So when we have large MPDUs, right, it makes a huge amount of sense. But given that the bulk of the airtime consumption is arbitration, it's extraordinarily inefficient with small frames. So there's actually a natural limit to the amount of unicast conversion that a channel can support. So dependent, and we see an unbelievable amount of reassociation and roaming happening from stations in these high density environments. So depending on how they behave, if they're doing the neighbor discovery every time they reassociate, and we're doing unicast conversion, we could like storm the channel. But so this is something we need to characterize. We've not characterized it, but I'm sort of inherently skeptical about it.
Okay. Yeah.
So I can share a little bit of information with some of the V6 deployments that I've had in the past. In higher ed, we had probably 60,000, this was a few years ago, we had about 60,000 concurrent subs on multiple controllers. This was with an Aruba deployment. And we had pretty good success with it, to tell you the truth. We used Slack. We routed everything. So the design in general was to have smaller subnets, even small for IPv6, like /48s to a building, which would be a ridiculous amount. But that gave us pretty good visibility. Some of the pain points that we saw at the time, which I don't know if they still exist because I'm no longer there, but some of the pain points that we saw were at the time when you would look at your user and your connected clients table, all of your V6 addresses would show up in there, including your V4, and trying to get filters on that was ridiculous. So you're trying to basically sift through your information, and you see all these the link local stuff and everything like that, and that was frustrating. So I know we kept trying to get feature enhancements to try to get that sub. You would know better if that's true, since you're Aruba. Right. But that was one of the pain points. And then the other pain point was, at the time we were running IP mobility, and getting dual stack clients on and working with IP mobility in a dual stack environment was a challenge. But that's where the whole, I haven't been doing this in a while. That was where we basically started doing IP mobility at layer 2 rather than layer 3. So you didn't have that big table, that you basically had to maintain. So you just had your list of MAC addresses for all your controllers, and that kind of solved the problem, which definitely eased our configs and made it easier. But the couple of things that I will say, because I am starting to get out of the lab in a service provider environment turning this on, that's best practice, whether or not you do Slack or DHCP-v6 or whatever you have, map out all of your flows. So start by every single one of your user cases and start making sure that you have your ACLs in line with this, right? So that's one of the things that people forget. You turn it on and then you're like, oh crap, I don't have everything, all of my user behavior and your SLAs that you're supposed to have for all your clients in place, because you don't have all your ACLs in place for your V6 stuff. So I know with my Aruba deployment in the past, they were good with the RA guard thing. So there was problems with that happened at higher ed. So we were able to run with that. But all of those ACLs are really important to try to nail down if you're thinking about it. Those are the things to test in the lab, to understand that you know what's going on. Not only that you're able to see your neighbor solicitations, your router advertisements and things like that, that you're starting to understand where that permeates, especially when you start seeing a V6 packet first, what's the treatment, all that type of stuff. Those are the things that you need, your little cookbook that you start to need to get in place. No matter what vendor you're using, no matter what you're doing, those are things that have to be done before you're going to turn on a V6 deployment.
Yep. Yeah, so I'll reiterate that RA guard. I think if you're going down the path of not deploying V6, or even if you decided you do want to deploy V6, RA guard is one of those things to make sure that I don't get rogue devices out there advertising prefixes, and then clients jump on that prefix, and now are they routing other than how I wanted them to, and those kind of things. Thank you. Any other questions, comments? Yeah.
It's more just about feature parity. Some of the advanced features we're using in the controllers are just not supporting V6.
I had to put a third of the camera.
So feature parity is just one of the things that was holding back us turning on v6 in some of our environments. You know, we've come to like things like layer 7 application inspection, visibility, all these cool things. So many vendors don't support inspecting traffic at v6, they're just bridging it onto the wire. And it's like, well, actually in our environment where we are running v6 dual stack, we see gigabits per second of traffic going to Netflix, YouTube, since Google, Facebook, those guys turned up v6. And if I can't account for that and inspect it in, you know, that's a big problem for us, so yeah. Yeah,
so two thoughts. I mentioned earlier, a lot of clients will prefer v6 if they get an address. So then you start to see the Facebook is a good v6 target, Netflix. Kevin, you had some others, I think, that were good for v6 from a internet.
Yeah, LinkedIn and Facebook.
Okay.
And Netflix are the big ones.
All right, so
all the Google services.
Right. So anything Google, and then LinkedIn was the other. So they'll prefer and start using that. The other piece, and that kind of goes back to my intended sarcasm or joke earlier, was as far as everybody running latest hardware, latest software, it's definitely a work in progress. So kind of knowing intimately, if you saw my presentation last year, warehouse design, knowing your clients, knowing your capabilities, the rest of that, a lot of that plays over here too. So it's understanding what is the infrastructure that I'm trying to run on top of. Do I have equipment? Do I have devices that can even offer RAs, or are they just using IPv6 from a pure management perspective and not intending to route? Am I trying to go dual stack? Am I trying to go v6 only? Those will all kind of have different impacts then on how we design things. And then just keeping track of what features are you using, what maps over, what doesn't, and making sure you're good before we get into it. Test where you can if you've got a lab, and do exactly that. The Wiresharks, the packet captures, understanding the flows, all good for understanding how the stuff's going to deploy once you roll it out. Yeah, Andrew.
So just more of a general comment, and I want your take on how learning IPv6 has been for you, because when I went through and I learned it, and guaranteed I haven't done like the large setups or anything, I've done home and I've done some small networks, but I found that there's a lot of fear around IPv6, and that when I got into it, it actually wasn't that bad, and it was just like a lot of perception that's holding it back, especially from an engineering perspective. So I just wanted to know your take on going through the learning process from an engineering perspective.
I think you and I got into it about the same time, if I remember right. You were actually blogging how to do the Hurricane Electric setup. I kept that all to myself. But there is that, right? I think a lot of the fear, which shouldn't be anything new for us, a lot of the fear is the way the standards have changed. You find Microsoft clients that like to try and build Teredo tunnels and figure out how they're going to get 6 over a v4 only network. There's competing kind of, do I do 6 over 4, 6 and 4, a lot of different ways to do v6 tunnels. And so it leads itself to this idea that there's just so many different concepts or so many different ways of doing the same thing. Do I really want to go learn all that? If you look at kind of how fast Wi-Fi evolves and we go through different standards, I don't think it's anything different. In fact, probably a little slower than what we're used to dealing with. So when you actually get into it, and again, there's some great resources out there. There's another Hurricane Electric's got a certification program that you can go through that kind of steps you through different tiers, basic addressing information, kind of stepping on up through the rest of it. There's another new, I've seen it on Twitter a number of times, I'm drawing a blank on what the certification is now. Yes, GoGo6. Another great way to get hands-on some different learning material, and then just play with it in the lab. If you can set it up and do your packet captures, grab the packet flows, see how it's working, and just go from there. But you can't break anything, so easy to learn. Anything else?
As far as the question about DHCP v6, there's actually some clients that don't support it, like Android. So
Okay.
If you're doing a large deployment with mobile devices, the Androids are out of the picture if you do v6 only.
Do they Do they not do V6, DHCP v6 at all? Or do
No,
they not?
they don't
won't
support it. I'm sure Google has some reason why they don't do it,
Okay.
but you have to run Slack if you want it.
Okay.
Another thing too, for your DNS, you need to make sure your IPv4 DNS servers return IPv6
Yes.
addresses, or you could have an IPv6 address and never go to any sites with it.
So 2 good points. DNS has got different infrastructure. It gets a little bit more than what I was intending to cover from a Wi-Fi guy perspective, but there are quad A records inside of DNS, so when you go to look up what is www.google.com, it'll respond back with an A record, which is the IPv4 address or a series of V4 addresses. There's a quad A record that does the same thing for V6. So it's making sure that if I want devices to talk, I've got to enable it at the infrastructure side, but then I also have to make sure that DNS and the other services that build on top of that are also responding with it. If I try to resolve a site and I only get an A record back, then I can only talk on V4. There was a second piece I was going with that, and I've lost it. So, oh, and then browsers. So if we're used to doing things like I'm doing over here, statically jumping into different machines, the whole URL changes a bit. It's instead of having a HTTPS:// and your IP address, your IPv4 address, you actually get into putting it in brackets to signify that it's a V6 address. So some of your browsers will behave a little bit differently. It took me a bit to learn it, and it's kind of a good way to tell where the product is in a roadmap perspective. If you try to do a ping or you try to do trace route, some of those things, and give it an IPv6 address, and it complains about semicolons or colons instead of the dotted decimal format, you have a pretty good idea either that's the wrong utility or that OS just doesn't support IPv6 at all. Anything else? All right, I appreciate everybody's time. At Charlie Clemmer on Twitter. If you have any questions that come up after the fact, hit me up, and we'll see you guys next year.
Okay, one more time. Clap really loud so Devin knows it's time to quit.